Welcome to this edition of Miss Max Academy. We're in Chapter 22 QuizA, question number 1. Let's take a look at the prompt. Great Britain has a great literacy tradition that spans centuries. One might assume, then, that Britons read more than citizens of other countries. Some Canadians, however, feel that a higher percentage of Canadians than Britons read. A recent Gallup poll reported that 86% of 1,004 randomly sampled Canadians read at least one book in the past year, compared to 81% of the 1,009 randomly sampled Britons. Do these results confirm a higher reading rate in Canada? Our first step is to state the null and alternative hypotheses. We know that the null hypothesis is always a statement of no change. There we go. Just a couple of extra clicks. So our null hypotheses here would be P subscript C minus P subscript B is equal to 0. Generally, I like the smaller proportion to be subtracted from the larger. And then our alternative hypotheses, do these results confirm a higher reading rate in Canada? Well, that would mean that the proportion of Canadians who read would be greater than the proportion of Britons who read. Okay, so now that we have our null and alternative hypotheses, we are going to check our conditions. So first, the randomization condition. The Britons and Canadians were randomly sampled by Gallup, and that is told to us in the prompt. The 10% condition. The number of Britons and Canadians is greater than 10,090, which is 10 times 1,009, and 10,040, which is 10 times 1,004, respectively. So that's our 10% condition. Independent groups. The two groups are clearly independent of each other. Success failure condition. Of the Britons, approximately 817 read at least one book. And the 817, let's see, the Britons, blah, blah, blah. It would be 81% of 1,009. So you do 0.81 times 1,009. And you get 817.29, but we cannot have 0.29 people, so we round to the nearest whole number, and that would be 817. That's where this number came from. Approximately 817 read at least one book. That means 192 did not. Of the Canadians, approximately 863 read at least one book, and 141 did not. The observed number of both successes and failures in both groups is larger than 10. Yeehaw! Our conditions have been met. Okay? So because the conditions are satisfied, we can model the sampling distribution of the difference in proportions with a normal model. We are going to perform a two-proportion z-test. So first, let's take a minute and find our p-pooled value. So P pooled would be X subscript C plus X subscript B over N subscript C plus N subscript B. And just a reminder, X subscript C is the number of successes of Canadians, or the number of Canadians who read out of the total number of Canadians. This is the number of Britons who read, and this is the total number of Britons. And when you do the math, you get your P pooled value of 0.835. And just a reminder, we always pool for hypotheses test for two proportion z-test. Okay? All right, so we have our P pooled. Next, we're going to find the standard error of P pooled. And here's our formula for the standard error of P pool. Hopefully this formula looks familiar to you. It's P pooled times 1 minus P pooled over the total number of Canadians that were surveyed. P pooled times 1 minus P pooled over the total number of Britons that were surveyed. And we plug it in, plug it in. Here's our P pool value. This is 1 minus P pool. And when we do the math, we get 0.0166. I went up 4 places after the decimal. And of course, we always need to find our z-score. And just a reminder, the observed difference in sample proportions was equal to 0.05. Okay, so the difference between the proportion of Canadians who read and the proportion of Britons who read, the difference was 0.05. Finally, we want to take a minute and find our z-score. And here's our formula for the z-score. It's just observed statistic minus the parameter. And when we have a 2 proportion z-test, the parameter is always 0. There's no change between the two, all over our standard error. So again, I plugged it in. So here is the difference in my sample proportions. I divide that by the standard error, and I get a z-score of 3.01. Already I'm coming to some rough conclusions here. I'm saying, gee, a z-score of 3.01 is pretty unusual. So let's take a look over here at my graph. So here I have this graph whose parameters are 0, 0.0166. Again, this is a 0 because we assume that there's no difference between the two. There's no difference between the proportion of Canadians who read and the proportion of Britons who read. So here's our 0 parameter, and here is our observed difference in the statistics, which is 0.05. They correspond, the 0.05 corresponds to a z-score of 3.01. And when we use our calculator and find the area under the curve for z is greater than 3.01, we get the probability of that happening is 0.0013. And that makes sense to us because we know anything beyond 3 standard deviations from the mean is highly unusual. And this number here has a special name. We call it our p-value. And our p-value is the probability, again, that z is greater than 3.01. And that probability is very, very small. It's 0.0013, or roughly 0.13%. So we're ready to draw a conclusion. So here we go. Here's our conclusion. With a p-value of 0.13%, that is well below our alpha level of 5%. Notice there was no alpha level given in this problem, so we assume an alpha level of 5%. Therefore, if we have a small p, we reject the null hypotheses. That means there is strong evidence to confirm a higher reading rate in Canadians than in Britons. All right, so let's take a minute and check our information with our calculator. Just a reminder, we call this a 2 proportion z-test. So in our calculator, we're going to hit our stat key. We're going to arrow over to tests. We're going to arrow down to 2 proportion z-test. Make sure you plug in the proper data. And here you go. This is what it should look like. This is our proportion of Canadians. This is not the proportion. This is the number of Canadians who read out of the total number of Canadians in the survey. This is the number of Britons who read out of the total number of Britons in the survey. Again, our alternative hypothesis was a greater than statement, so make sure you've highlighted that. And if you hit calculate, you get this information. You get a z-score of 3.009, which we rounded to 3.01. you get a p-value of 0.0013, and that's what we got here. You see the proportion of Canadians who read is roughly 0.86, rounded 2 places after the decimal. The proportion of Britons who read is 0.81, rounded 2 places after the decimal. Here is our p-pooled value, 0.835, rounded 3 places after the decimal. And again, you see that right here. Okay, so again, we've confirmed our p-value. We have our z value. And finally, let's just go back to our 2 proportion z-test, and this time hit draw. And you see, when you get the curve, again, it gives you your z-score, 3.0096, and your p-value of 0.0013, and you almost can't even see the area under the curve. It's that unlikely to happen. Well, I hope this helped clear up any confusion you might have. Again, this is Chapter 22, Quiz A, Question 1. Tune in again for help from Miss Mac.